Hey guys, this is Pinpoint. In this video, we will talk about the set of values used to represent different quantities, which is known as the number system. And there are four types of number system. We have the binary, the decimal, the octal, and the hexadecimal. When we type letters, words, or numbers, the computer translates them into binary numbers, as computer can understand only binary numbers. And computer represents all kinds of data and information in binary numbers. It includes audio, graphics, video, and of course, text and numbers. So, what is a binary number? When you hear the prefix by, what do you think of? By means 2, so the binary system is a base 2 number system, having just two digits, which is 0 and 1. Since computer works on electricity, we can use these two states, 0 and 1, to represent each number or character. 0 means the system is off, and 1 means the system is in on state. 0 could also represent as no, and 1 for yes, 0 for false, and 1 for true. Since each digit of a binary has only two values, each digit represents an increasing power of 2. For example, a binary 01, 00, 0001, the rightmost digit in a binary is called LSB, or the least significant bit, which has a positional value of 2 raised to 0. Next is 2 raised to 1. After 1 is 2, so 2 raised of 2. We have here an increasing power of 2. Again, each digit represents an increasing power of 2. So after 2, we have 3. So next digit is 2 raised to 3. Next is 2 raised to 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7. And the leftmost digit in a binary is called the MSB, or the most significant bit. Then we're going to simplify this one. 2 raised to 0 is equal to 1, or any number raised to 0 is equal to 1. Then 2 raised to 1, or 2 times 1 is equal to 2. Then 2 raised to 2, or 2 times 2 is equal to 4. Then 2 raised to 3, or 2 times 2 times 2 is equal to 8. 2 raised to 4 is equal to 16. 2 raised to 5 is equal to 32. 2 raised to 6 is equal to 64. And 2 raised to 7 is equal to 128. Then we're going to multiply 1 and 1 is equal to 1. And 0 multiplied by 2 is equal to 0. 0 multiplied by 4 is equal to 0. Any number multiplied by 0 is equal to 0. So this one is 0. This one is 0. And 1 multiplied by 64 is equal to 64. And 0 multiplied by 128 is equal to 0. Since zeros represent the off state, we will not include them. We will just take 64 and 1, and we will add 64 and 1 to get the sum, which is 65. And 65 in ASCII table, or American Standard Code for Information Interchange, is equivalent to letter A. Yes, the binary equivalent of letter A is 0, 1, 0, 0, 0, 0, 0, and 1. Every time you press letter A on your keyboard, 2 of the 8 switches will turn on. This one and this one. And the switches represent a number as large as 8 by turning all of them to on. And with binary, these switches can represent a number as high as 255. Because again, in binary, each digit represents an increasing power of 2. So the first switch has a positional value of 2 raised to 0. Next is 2 raised to 1. After 1 is 2, so 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7. And again, any number raised to 0 is equal to 1. 2 raised to 1 is equal to 2. 2 raised to 2 or 2 times 2 is equal to 4. 2 raised to 3 or 2 times 2 times 2 is equal to 8. 2 raised to 4 is equal to 16. 2 raised to 5 is equal to 32. 2 raised to 6 is equal to 64. And 2 raised to 7 is equal to 128. And since they are all in on state, we will get the sum of all the numbers. 128 plus 64 is equal to 192, plus 32 is equal to 224, plus 16 is equal to 240, plus 8 is equal to 248, plus 4 is equal to 252, plus 2 is equal to 254, and plus 1 is equal to 255. And again, in binary, these 8 switches can represent a number as high as 255. And a single switch is known as a bit, which stands for binary digit. And a byte is 8 of these switches. So in short, 8 bits is equivalent to a byte. And next we have the decimal number. When you hear the prefix deci, what do you think of? Deci is a decimal unit prefix in the metric system denoting a factor of 1 over 10. And when I hear that term or the prefix deci, I also think of the word decade, which corresponds to, of course, 10 years. And I also think of a decagon. A decagon is a polygon with 10 sides. So, deci is associated with number 10. Hence, the decimal number system is a base 10 number system because it uses digits from 0 to 9. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. A total of 10 digits including the 0. And this system is used for everyday counting. Like for example, 25, 150, 500, 1000, 2000, 5000, and so on. We use decimal system to represent numbers. And decimal number system is also a positional value system, which means that the value of digits will depend on its position. For example, we have here 1243 base 10 or decimal. The value 3 is in ones position, the value 4 is in tens, the value 2 is in hundreds, and the value 1 is in thousand position. So 1243 base 10 or decimal can be written as the value of 1 is 1000 or 1000 or 1 times 1000 or 1 times 10 raised to 3. 10 raised to 3 is equal to 10 times 10 is equal to 100 times 10 is equal to 1000. So 1 times 1000. Next, the value of 2 is 200 or 200 or 2 times 100 or 2 times 10 raised to 2. 10 times 10 is equal to 100 times 2 is equal to 200. Next is the value 4 can be written as 4 times 10 raised to 1. 10 times 1 is equal to 10. So 10 times 4 is equal to 40. Then the value of 3 can be written as 3 times 10 raised to 0. Again, any number raised to 0 is equivalent to 1. So 1 times 3 is equivalent to 3. So the weightage of each position can be represented as this one, 1, 2, 4, 3. So again, since this is a decimal number, so the rightmost digit has a positional value of 10 raised to 0. After 0 is 1, so 10 raised to 1, 10 raised to 2, and 10 raised to 3. Then again, any number raised to 0 is equal to 1. So 10 raised to 0 is equal to 1. 10 raised to 1 or 10 times 1 is equal to 10. 10 raised to 2 or 10 times 10 is equal to 100. And 10 raised to 3 is equal to 1000. So 3 times 1 is equal to 3. 4 times 10 is equal to 40. 2 times 100 is equal to 200. And 1 times 1000 is equivalent to 1000. So to get the sum, we'll add this one. 1000 plus 200 is 12 plus 40 is 1240 plus 3 is equal to 1243. So we still get the same value, 1243, by using the increasing power of 10. So next we have the third type, which is the octal. When you hear the prefix octa, what do you think of? Me, I think of an octagon. Octagon is a polygon with 8 sides. So octa is associated with number 8. So the octal number system is a base 8 number system. Because it uses numbers from 0 to 7, we have 0, 1, 2, 3, 4, 5, 6, and 7 to represent the numbers. So again, 0 to 7, a total of 8 including 0. Octal number system is also a positional value system, where each digit has its value expressed in power of 8. For example, we have here 1, 2, 3 octal. So we have 1, 2, 3. Since this is octal, so the rightmost digit has its positional value of 8 raised to 0. Next is 8 raised to 1 and 8 raised to 2. And again, any number raised to 0 is equal to 1. And 8 raised to 1 or 8 times 1 is equal to 8. And 8 raised to 2 or 8 times 8 is equal to 64. So 3 times 1 is equal to 3. 2 times 8 is equal to 16. And 1 times 64 is equal to 64. And we'll get the sum. 64 plus 16 is equal to 80. Plus 3 is equal to 83. And you'll notice that the base value is 10 or 83 decimal. Because decimal equivalent of any octal number is the sum of product of each digit with its positional value in octal. Okay? Then next we have the hexadecimal number system. What do you think when you hear the prefix hex? Me, I think of a hexagon. Hexagon is a polygon with 6 sides. Hex is equal to 6 and decimal is equal to 10. So 6 plus 10 is equal to 16. Hence, hexadecimal is a base 16 number system, which comprise of 10 decimal numbers, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 digits including the 0. And the first 6 letters of the alphabet, A, B, C, D, E, and F. And letter A corresponds to 10 in hexadecimal number system. B corresponds to 11, C to 12, D to 13, E to 14, and F corresponds to 15. And hexadecimal is also a positional value system, where each digit has its value expressed in power of 16. For example, we have here 10 FB base 16 or hexadecimal. So in 10 FB, since this is hexadecimal, the rightmost digit has a positional value of 16 raised to 0. Okay? And next digit is 16 raised to 1, 16 raised to 2, and 16 raised to 3. And again, any number raised to 0 is equal to 1, so 16 raised to 0 is equal to 1. 16 raised to 1 or 16 times 1 is equal to 16. 16 raised to 2 or 16 times 16 is equal to 256. And 16 raised to 3 is equal to 4096. Then we're going to simplify this one. We will change letter B to its corresponding hexadecimal value, which is 11. So 11 times 1 is equal to 11. Then again, change letter F to its corresponding hexadecimal value, which is 15. So 15 times 16 is equal to 40. And any number multiplied by 0 is equal to 0. So 0 times 256 is equal to 0. And 1 times 4096 is equal to 4096. Then just sum it up. So 4096 plus 0 is equal to 4096. Plus 240 is equal to 4336. And plus 11, so it is equal to 4347 decimal. And again, decimal equivalent of any hexadecimal number is the sum of product of each digit with its positional value. And to wrap up, number system use different number bases. 2 for the binary, 10 for the decimal, 8 for the octal, and 16 for the hexadecimal. And a base indicates the number of digits available when using a particular system. Like for example, a binary, it is a base 2 number system which uses 2 digits 0 and 1. A decimal, a base 10 number system which uses 10 digits from 0 to 9. Octal, base 8 number system which uses 0 to 7 digits. And hexadecimal is a base 16 number system which uses 10 digits from 0 to 9 and the first 6 letters of the alphabet A, B, C, D, E, and F. And the value of any digit in a number can be determined by the digit, the position, and by its base. Thank you for watching, and I hope you find this video helpful. And please don't forget to like, comment, share, subscribe, and hit the notification bell icon so you'll be notified on my next video.